What's good, you guys? C.A.S.T back with another video. Today we're getting into part 2 of my How to Water Cool a PC series. We're going to be going over radiators and fans, primarily radiators, but I'm going to throw in fans anyways because they're kind of like joined together. No pun intended. For demonstration purposes, I'm going to use my old school Arctic liquid freezer. This is the original Arctic liquid freezer for those who don't know. Basically an C.A.S.T 360 AIO. But essentially, there are certain things that you need to know about radiators and fans when water cooling a PC. I'm going to give you kind of like in-depth detail on what is important, but also kind of like give you a macro scale TLDR on what you actually should be focusing on, because at the end of the day, it's relatively hard to get the wrong radiator combo unless you do something seriously wrong with your setup. But this is just information that should be helpful for you to pick the right, radiator size, radiator type, fan size, fan type, so on and so forth for your specific build. Now again, this is going to be primarily from a function standpoint rather than a form standpoint. I do know that I talked about in the past video that form is kind of like the more important, advantageous part of custom water cooling. Still, we want to be able to make the most optimized setup for actually keeping our CPU and GPU and other water cool components under control. There's no point in spending this kind of money and not getting best-in-class performance. So let's start talking about the most important aspect of a radiator, and that's going to be the overall size. For demonstration purposes, it's a 360mm radiator, and for those who don't know, that's with reference to the actual length, or the y-axis if this was standing up in your case, of how long the actual radiator is. Now technically, this radiator is a little bit longer, and most radiators that you're going to be shopping for will be dimensionally longer than 360mm. But that's just with reference to the distance between the top and bottom where the fan mounts are. So a 360mm rad in the industry usually is going to mean you have provisions for 120mm fans. 3 times 120 is 360. In the same fashion, a 420mm rad would be 4 times 140, or 3 140mm fans. 280 is 2 140mm fans. A 240 is 2 120mm fans, so on and so forth. Technically, I guess you could do like 6 60mm fans, and that's also a 360mm radiator by, letter of the law. But we're talking about like normal, PC, use cases as far as gaming PCs and normal consumers, not like server grade hardware. That's where you see like a radiator that size, and you probably wouldn't even be able to find that radiator easily from your big retailers. So don't worry about that. The most important thing we're going to be looking at is actually being able to fit the radiator inside our PC case. And since the radiator actually is larger than 360mm, with regards to where the fan layout is, just because your case can fit 3 120mm fans does not necessarily mean it can fit a 360mm radiator. Usually with the AIO, you might have like an additional inch above and below the actual radiator to fit the end tanks, like this C.A.S.T AIO, for example. But with a custom radiator, that's going to be a lot larger. Sometimes the actual the width meaning that it's going to overextend the actual 120mm as far as like on the sides of the radiator. So you might run into clearance issues with your side panel or the back portion of the inside of your case. And then also the end tanks, different radiators are going to have different size end tanks, so you could run into fitment issues not lining up with the actual screws. You have provisions for 3 120mm fans, but not enough clearance to fit the full radiator. So just something to keep in mind. We want to actually pick a radiator that will fit inside our case. This is going to be on a case-by-case basis, no pun intended. And also, just look at the overall dimensions of your radiator. Usually, your radiators that are supported inside your case will come in your owner's manual or in some sort of literature online. If it's not from the actual manufacturer, you should be able to find a Reddit post for the big name cases that you're shopping for nowadays. And then you might just be able to look at a picture and obviously tell you, yeah, a radiator I'm shopping for will definitely fit inside. So that's the most important aspect. So we figured out the size radiator we need for our case. We've sized that up. It's going to fit properly. Now we need to focus on the other things. You're looking at your description of the different 360 radiators, for example, that you're shopping around, and you're like, well, what does all this information mean in the spec sheet? I'm going to tell you the ones that are important that you need to focus on and what they essentially mean. Starting off with the wattage rating and the fluid capacity of your radiator. Most brands are going to show like at least 1 or 2 of these specs for the radiator they're selling. If the radiator you're shopping for doesn't have either one of these, just my personal opinion, it's not worth buying because it's relatively important as far as how the radiator is going to physically perform. Starting off with the fluid capacity, this just essentially is what it sounds like, the amount of fluid that you're going to be able to fit inside the radiator, the volume. Now this is going to basically tell you how well the radiator will be at delaying the inevitable of reaching your equilibrium point, for your CPU, or how many parts you have that are putting heat into your cooling system. The best way I can describe this is, going back to the laws of thermodynamics and properties of water. Water is a really bad conductor of heat in comparison to metal. Best way to describe this, if you were to put a skillet on the stove and turn the heat on like a level 5, that skillet will heat up relatively quickly. You'll probably notice in the first 20, 30 seconds that skillet getting pretty doggone hot. In comparison, if you put a pot of water on the stove and put it at 5, it might take a little bit longer for that water to actually get hot in comparison to the skillet. And that's because metal's a better conductor of heat. It's going to reach its heat capacity much faster compared to water. Water is going to take more time to be able to reach its heat capacity, its kind of equilibrium point before it starts boiling. Now, if we have a CPU, and let's assume that all the other aspects between that could affect the overall end temperature, the equilibrium point temperature of your CPU are the static. The only difference is that we have metal versus water. An air cooler is going to be able to reach its maximum temperature, let's say 80 degrees, within the first 20, 30 seconds of you turning on your stress test. In comparison to our radiator in our 360 IO, it might take 2 to 3 minutes before you reach 80 degrees Celsius. It'll start out around like 74, 75 degrees, and then every 10, 15 seconds it'll go up a degree until you reach, 10 or 80 degrees, and then you reach your equilibrium point. That's where your steady state CPU is going to settle in at after 3 minutes versus 30 seconds. Because again, water is a worse conductor of heat. It takes longer for us to reach that heat soak point. The wattage rating is essentially the amount of wattage that your radiator can effectively disperse out into the atmosphere at a given time. It won't get overwhelmed. You want your wattage rating, and this isn't going to be the wattage power draw of your CPUs combined, all that kind of stuff. It's going to be your wattage rating as far as the heat output of your GPU, CPU, whatever you're water cooling into the cooling system. Those numbers are different. Is there an easy way to measure this? To my knowledge, no. I'll describe a little bit later down the line after I describe this how you can kind of gauge that. But essentially, the wattage rating of your radiator needs to be higher than the wattage output of heat of whatever you're water cooling in the system. And if you do that, you'll be able to maximize the performance of your cooling system. Now, it's not entirely the most important thing, and there's other ways you can kind of get around this with fluid capacity. But essentially, you want, again, like I said, your wattage rating to be higher than your CPU. If it's not, then you're going to run into issues. Now, getting back to that input-output, we want to be able to most efficiently take the heat source that's going into this cooling system and output it into the atmosphere. If our CPU is putting out, let's say, 400 watts of heat into our cooling system, but our radiator is only able to support 400 watts of heat that is actually able to put out in the atmosphere, there's going to be a disconnect, a delta of 100 watts, let's say. And where's that heat going to go? Well, it's already in the system, so it's just going to stay in the system. So you're going to see your temperatures continue to rise and rise and rise until cooling system basically to overheat, to basically continue to run away from itself. And then when the heat has nowhere else to go, because once you reach fluid capacity or heat capacity in the fluid inside your system, then the heat has nowhere else to go, so it's eventually just going to get stuck in the CPU, and then your CPU temperatures are going to continue to rise until you thermal throttle. And you thermal throttle by lowering the wattage power draw of your CPU, which will lower the heat output of your CPU, which will lower the heat input in the cooling system to a point to where your radiator is actually going to be able to output the heat appropriately. So that sounds pretty bad, right? You always want to make sure your radiator has a substantially more wattage output compared to your CPU or whatever you're water cooling. That is true, but also you have to take into consideration your use case, because this is only considering that we have that constant heat load being put in the system all the time, and we want to be able to maintain this for eternity. That's not realistic. And that's where fluid capacity can come into place and kind of combat that. My OptiThreads PC is a good example of that, because in a lot of cases, this CPU can overwhelm my cooling system. The wattage output of the 2990WX is higher than I'd imagine the two radiators are actually able to physically handle. Let's say that my CPU puts out 500 watts of heat. Not really sure what it is, but let's say it's 500 watts. Let's say that my setup is actually able to effectively handle 450 watts. So there's a 50 watt difference. So we're going to slowly be overwhelming the system, right? However, I have a reservoir in here that holds a decent amount more water. Probably most of the water in the loop is going to be held in this reservoir that's sitting in the top of my drive bay. That's a drive bay reservoir inside my Optiplex PC. So with the additional fluid capacity, we're going to reach that maximum temperature way slower compared if we just had we didn't have the reservoir. And that's a benefit for us because it's going to take us longer for us to actually overwhelm the system to the point that we're actually going to be seeing a decrease in performance. Yes, we're putting more heat into the system than we're actually able to extract from the system, but for the sheer fact that it's going to take much longer for that water to heat up because we have more water, we're going to be able to keep temperatures relatively low on the CPU for longer if we didn't have that water inside there. And depending on the workload we're actually doing, the workload could be over by the time the system gets overwhelmed. So even though the radiators technically don't have like that overkill kind of aspect, it's kind of like more equal middle balance, maybe slightly underpowered compared to what you would normally water cool a 2990WX on to overclock it appropriately and handle that wattage output. We're still able to not really see a difference in performance because whenever I'm video editing, I'm able to render a whole 30-minute video or whatever in like 20 minutes or so because the CPU is so doggone fast. And yeah, I can see the temperature climbing slowly, but by the time the video and rendering is done, I haven't reached that limit yet. Now, an example for a Cinebench run, like a Cinebench run, right? I don't run Cinebench indefinitely, but I will actually see my CPU start to thermal throttle probably 3 minutes into a Cinebench stress test if I was to keep it looping over and over and over again. Thankfully, Cinebench is not a real-world scenario. It's made to beat the crap out of your CPU and have a way higher wattage rating or wattage output compared to what you would do in a normal case. So technically, from my standpoint, I'm only going to do a single run of Cinebench just to see how my CPU performs. I already know that's going to thermal throttle eventually, but 3 minutes of Cinebench means that I'm pretty much going to be able to do whatever I want with this PC, even though the cooling system is technically too small, just from the wattage rating of the radiators. I have enough fluid capacity, and I have a efficient enough water block that where I'm going to get that heat at least off the CPU into the system, and by the time my workload is done on the CPU, I don't have to worry about the heat capacity reaching its limit just yet. So you can kind of balance like a balancing act of wattage rating versus heat capacity or fluid capacity as far as which one you want to optimize. Now, in most scenarios, you're going to want to lean on the side of wattage rating and getting appropriately sized radiator that's going to have a significantly higher wattage rating than your actual components are outputting. But again, this all comes down to other external factors beyond just the physical performance and function of your system. How much is this overkill radiator going to cost? Is it still going to fit in my PC case? How easy is it going to be to drain if I have this way bigger radiator? How much heavier is my PC going to be able to transport it around and put it on my desk? Is that going to cause an issue? A lot of different aspects beyond just the performance of your radiator. If you can get away with a radiator that technically has a lower wattage rating, but for your specific workload, it's not going to make a big difference in temperatures at all, then maybe it's better to go down that route. For my Optiplex PC, I'm size constrained. I can't fit a giant 420mm radiator like a lot of people did with two 360 radiators like a lot of people did with the 2990 that will allow you to run Cinebench stress tests for 24 hours straight and not cause sweat on the CPU. But I'm not doing that with this workload. I never would do that with this CPU. And I don't really play games on it either, and even if I did play games, they're not pushing the CPU that hard. The most I'm doing with this is video editing, and it takes me roughly 30 to 40 minutes to render a video based on what I usually record and how long my videos are, so I'm never going to thermal throttle with this setup. Compared to my gaming PC, if I was running a 14900K, I'm running a 1500 3E, but I still have an overkill CPU or radiator in that one, so I can take advantage of a super efficient radiator or water block, on my CPU and also my GPU eventually. So where, regardless of how long I game on my PC, the CPU is going to stay at the exact same temperature. I could game for 8 hours straight, and the CPU is not even going to sweat. Kind of like a drag race application or like a race application versus like a road trip application, depending on how you want to set up your system. So the next aspect we're going to talk about is going to be the FPI number and then the number of tubes on the inside of your radiator. Both of these aspects are going to directly basically determine the wattage rating of your radiator, which we talked about in length at this point. These lines that you see running the vertical length of the radiator, these are the actual physical tubes on the inside. This is where water actually runs through the radiator. This is a Dual pass radiator, so water will enter through one side, cross through half of the radiator, collect at the intake here, be pushed back through the other half, go out the other tube, and then the cycle continues. The fin density, or the FPI number, is talking about the actual fins. If you don't see, there's like a zigzag stack of soldered metal running the lengths between the tubes. This is just to add surface area to the actual tubes themselves. Technically, you could just remove these fins altogether and just run the fans, like moving air through against the tubes, but that's not going to give you the most performance because you can greatly increase the surface area of where that heat can go, because again, the heat's entered in through the system, it's in the water, it's going to be transferred from the water to the actual tubes, to the actual fins on the radiator. So you can get significantly more surface area for that heat to collect at, for air to effectively remove it from the system, is the thought process there. Now again, just like the wattage rating and the fluid capacity, the fin per inch number and the tube number on the inside of your radiator is going to be a balancing act just like before. You can manipulate the FPI number and the number of tubes inside your radiator to overcome the physical dimensions of the radiator itself. A 240 millimeter radiator would always perform worse than a 360 millimeter radiator, which would always perform worse than a 420 millimeter radiator, if all those other numbers were the same. However, you can effectively increase the performance of a 240 millimeter radiator to be on the same level of a 360 millimeter radiator if you increase the number of tubes on the inside and also the number of fins. You could have a 360 millimeter radiator. However, if you only had one tube and one fin, then you have a really small channel of water to go through and really small surface area, so that it's not going to be able to take advantage of how big the actual physical radiator is itself. If you had a 240 millimeter radiator with 10 tubes and 10 fins, it's going to significantly perform better than the 360 millimeter radiator with one tube and one fin. It's an extreme case, but just to show the example so it makes sense to you guys. Going back to my OptiThreads PC, I am size constrained on the size of physical radiators I can fit inside. I can only fit a 140 millimeter radiator in the front and a 92 millimeter radiator in the back. So to overcome that, for one, I have thicker radiators, so they're like 54 millimeters thick, versus like the normal radiator you'll see on the market is usually 30 millimeters thick, so almost double. So it almost has double the fluid capacity than a normal 140 or a normal 92 millimeter radiator. So from the fluid capacity, I'm probably close to that of like a 240 millimeter radiator compared to a 140, between a 240 and like a 360 actually, if I was comparing it to like AIOs. However, both of those radiators have significantly higher tube count and a significantly higher fin density compared to your normal radiators on the market. They're made for high performance. And that allows the 140 millimeter radiator in the front to perform probably closer to that of a 360 millimeter AIO, even though it's physically a single 140 millimeter radiator. So that's how you kind of overcome that. However, you can't just increase this number to 1 million, right? If that was the case, every single radiator would have like an infinite number of tubes and an infinite number of fins, because you have infinite number of cooling at that point, right? In the smallest package possible. Well, you have to realize that these things actually take up space too. And you still need to be able to transfer air from one side of the radiator to the other. So the more tubes you have, the more fins you have, and you're making that more and more dense on the same physical constraints of the actual outside dimensions of the radiator. You're decreasing the amount of space you have for air to actually travel through from one side of the radiator to the other. So that's where you have to like get into high performance fans, high air pressure fans, to be able to effectively move air from one side of the radiator to the next. And this is where you kind of will see radiators that are, say, like they're optimized for sub 1000 RPM fans, or they're optimized for high RPM fans. This is directly being influenced by the thickness of the radiator, but also the fin density and the number of tubes on the inside, because the actual space for air to go from one side is either going to be tighter or more open, depending on the radiator you choose. And this is where you're going to find, like, when all this puts together, you're going to find some radiators are more efficient in certain scenarios versus others. Going back to my gaming PC versus my OptiThreads PC, they're basically on opposite sides of the spectrum. My OptiThreads has a Hardware Labs GTR 140. In comparison, I have a 360 millimeter radiator. It's an Alpha Cool Monster radiator. It's really thick, but it has a really terrible fin density. The tube count is relatively similar, but the fin density is like terrible. The fin density is like pretty much half compared to what you would see even like on an AIO, for example. Very, very wide open. But they both perform really well for their specific use cases. Now, like I said, with the OptiThreads PC, I am limited on the actual physical constraints of the radiators. So I'm trying to get as most performance as possible out of this small package. Increase the fin count, increase the tube count. However, I need a high performance fan that's going to be able to pair that to be actually be able to physically brute force air from one side of the radiator to the next because it's thick and dense. Same for the 92 millimeter radiator in the back as well. Well, that means that I can't run quiet fans because quiet fans are not going to spin as fast and they're not going to move air as efficiently. So I need high performance fans. The 92 millimeter fan on the rear radiator spins up to like 3,500 RPM. The fan on the front spins up to 2,000 RPM. It's 140 millimeter fan and it's like 38 millimeters thick. So that's getting me a crazy high CFM number and a higher static pressure number compared to what a normal quiet or kind of optimized airflow static pressure fan would give you. In comparison to my 360 millimeter radiator that I talked about, the Monster, I can put pretty much whatever fan I want on there and run it at whatever RPM I want on there because the fin density is like non-existent. That even like airflow fans, even like cheap fans that you get from Amazon that have terrible specs, are able to effectively move air from one side of the radiator to the next. Now I have Fantex T30s installed on there, and I have like some cheap spiral LED fans on the front. But even before I put the T30s, those cheap fans I got on Amazon that I just show for aesthetics, they were able to. I still felt like a decent amount of air moving through the radiator because the fin density was pretty much non-existent. So even airflow fans, not optimized for radiators, worked fine on it. And the T30s, they spin at like 500 RPM and they still move a bunch of air through the radiator because, again, the fin density is non-existent. Now, in contrast, there's really no point in running those fans at like max RPM because I'm already getting the most performance as far as like efficient movement of air through the radiator because it's not that dense. So just spinning the fans faster doesn't get me any more performance. But that optimizes because I can run the fans at a lower RPM and basically get the same performance out of the radiator as if I had a higher RPM. So I don't even have to like have high RPM fans. I can get like quiet fans that will make the system quieter. So as you can see, the actual radiator you choose is going to determine what type of fan you choose. Like I said, for my gaming PC with a low fin density and just really thick, just basically brute forcing it through fluid capacity, I can pretty much put whatever fan I want on there. I'm picking fans based on aesthetic versus actual performance. However, with my OptoThreads PC, I have to pick a fan that is best suited for the actual radiator. Has enough CFM, it has enough static pressure to actually take advantage of moving air from one side of the radiator to the next. So the radiator you choose, there's no best radiator, there's no best fan for water cooling performance unless you're looking at like running your fans at like max RPM all the time, which isn't the case. If you want to build a quiet PC, there's a specific radiator for you. If you want to build a small form factor PC, there's a specific radiator for you for the performance you need, but you might be giving up on some other aspects. The radiator I have in my gaming PC is great and it's really quiet, but it's huge. It's humongous. The radiator in my OptoThreads PC is small and compact and performs really well, but I need a fan that spins really fast and gets really loud. So, there's just different things you have to take into consideration when picking both radiator, and then the radiator will definitely impact what fan you pick. And then, fans, you already know they have their CFM number, their static pressure number, their fan blade design, the actual RPM they spin at. All that stuff is basically going to determine how well it's able to move air from one side of the radiator to the other side. So pick whatever you need. CFM and static pressure numbers are probably what you want to focus on, and then go from there. Pretty much every single radiator worth buying now is made of copper. You can buy aluminum radiators. They have their place. I'm not going to sit here and tell you they don't. For one, they're significantly cheaper. In some cases, I do think they have a performance advantage over copper radiators, but like they're in weird use case scenarios. But you're going to be running mixed metals because most water blocks are going to be made of copper. So that's not going to really work unless you have a mixed metal coolant. You can get antifreeze if you want to do it cheaply, or just get a mixed metal coolant from a manufacturer. But you can't use like distilled water or one of like your over-the-shelf coolants because those are not going to work really well with mixed metals. So just stick with copper radiators. Most of your water blocks out there are going to be copper, so just stick with copper radiators. Actually, you don't have to like really go out of your way to find an aluminum radiator from like your big brand manufacturers, so not really something you need to worry about from that standpoint. Build quality just comes down to the brands you trust. I trust Hardware Labs. I think they're the best brand, and most people will say the Hardware Labs makes the best radiators on the market. I think they make like OEM for Bits Power. They make OEM for Corsair and other manufacturers out there as well. Alpha Cool, also tried and true. Those are the two that I mainly have experience with. But even the companies like Barrow and Bixby, they make radiators. I've heard really good things about them, and they're a little bit more on the budget side. So even stuff coming out of China, even though like back in the day wasn't the greatest, you can still find pretty decent stuff. Even like on AliExpress, like the manufacturing of these radiators has come a long way compared to what it was 10 years ago. So brands, I have the ones I choose I like, but you can choose yours as well. I will say one thing about Hardware Labs, even though they do technically perform the best, and they probably are the best radiator out there on the market, they aren't the most compact. They're not the most attractive looking, if that matters to you, and also they don't have drain ports, which is a huge problem, at least in a lot of cases. I have a Hardware Labs radiator on my AIO setup for my 9590, and draining that system is a pain in the ass. If I had a drain loop and like I'd be able to like easily get air out of the system, like the Alpha Cool radiator I have in here, it has multiple ports where you can put fittings and whatnot as a drain port on the bottom. So actually physically filling and draining the system is easy with that. With Hardware Labs radiators, you kind of have to finagle it, and like it takes a little bit more work, but they still perform really great. So once it's done, it's kind of done. Doesn't really matter to me at that point.
Now, I think the last aspect of radiators that you'll see, at least in reviews, not really advertised, but at least in reviews online, is going to be with regards to the pressure drop. When you have a radiator or any other component in your loop, it's going to add resistance to the fluid moving through it, and it's going to cause a pressure drop of the actual fluid across the system. So depending on your pressure drop, it's going to, I guess, technically affect how the fluid is going to move through your system, the flow rates, all that other kind of jazz. That could possibly affect the actual performance of your system. In comparison to like CPU blocks and GPU blocks, radiators have significantly low pressure drop to where even if you are able to measure it compared like from one radiator to the next, it's going to be negligible in the overall comparison of the pressure drop across your system. If you're worried about pressure drop, you should probably be looking at like the most restrictive CPU blocks, and then maybe the GPU blocks you're looking at, and then how many things you are water cooling. But like in most cases with a CPU and a GPU and that's it, you're water cooling, the pressure drop across those components is not going to make a big of a difference. And if it does make that big of a difference, you just legitimately need a more powerful pump. So unless you were trying to run like 4 GPUs in parallel with a really restrictive CPU block and then a bunch of like restrictive radiators on a eBay or Amazon like fish tank pump, then you're really not going to run into any issues. You're buying normal brand stuff, DDCs or D5s, or one of the other like branded properly performing water cooling pumps. It's really not anything to worry about. So pressure drop, worth noting, but only in niche use cases. If you're watching this video, it probably doesn't apply to you, so don't worry about that. So I know that's a lot of information, guys, right? I'm sure you're overwhelmed. I'm sure some of you guys are just like, I just want to know what size radiator I need just to get my system to not thermal throttle and work. Well, there's different ways to think about this, right? If you're building a custom water cooling loop, what did I say in the first video? You want it to look good. You want it to look custom. You want it to look one-off. It's all about form, and also function's important, but mainly about form nowadays. So if you bought a case for water cooling, like a Leon Leo 11 Dynamic, and you have room for big 360mm radiators, you should probably put a big 360mm radiator inside of it, regardless of what CPU and GPU you're using. If you do it that way, you'll probably be okay. You'll probably have overkill, and you'll be perfectly fine. If you want to do it like a more by the book way with numbers actually associated to it, for every 100 watts of power draw you want to have at least a 120mm worth of radiator. And this is assuming that the radiator is like 30mm thick and performing at what a 120mm, 30mm thick quality copper radiator should perform like. So if you have a 100 watt CPU, I'm talking like a 200 watts, not like it's rated 100 watts on the box, but it actually draws like 150. If your power draw for your CPU is 100 watts or less, you could put a 120mm radiator on there for AIO, and you'll probably be okay. But now we're talking about like custom loops, so now we have a more efficient radiator with better performance than the AIO, better materials, more tubes, more FPI, and you have a quality like water block on top of there. You'll probably be better off, like you'll be good. Your temperatures will be fine. And then 200 watts. If you have a 200 watt CPU, 240, you're going to be good to go. 300 watt CPU, 360mm custom AIO or custom radiator, you'll be good to go.
And right, you can mess around with the thickness, whether you want a 45 millimeter thick, 30 millimeter thick, regardless. If you follow that rule, you'll probably be okay. But yeah, that's pretty much what you need to focus on with radiators and fans, guys. Hopefully the information I gave you is helpful. If you guys are overwhelmed, I mean, coolers like this still exist. You can just go and buy these and call it a day, like I was saying before. For the majority of people, it's going to be a lot simpler, but hopefully that information I gave you makes sense and you're able to now pick the proper radiator for your setup, whether you want to have max performance and noise be damned, or you want the quietest system and you want to make sure you still have good temperatures, or you want to cram everything as possible in a really small package. There's a radiator out there for you, which will then determine what type of fan you need to pair with for the best performance for your system. So hope that makes sense, guys. I'll catch you in the next video. I'm out, guys. Take care.